Welcome to my video lecture series in Object-Oriented Programming. This is Professor Janice Raymond Tan from the College of Computing and Engineering. For this video lecture, we will cover the topics about class diagram using Unified Modeling Language or UML. Throughout this video, we will discuss Unified Modeling Language, class diagram, and translating class diagram into code. The Unified Modeling Language or UML is a standard language for specifying, visualizing, constructing, and documenting the artifacts of software systems as well as for business modeling and other non-software systems. This lesson focuses on the importance of UML diagrams such as class, use case, sequence activity, component deployment during software development. It has been found that all the UML diagrams plays vital role in software development, but class diagram is the most favored diagram. UML or Unified Modeling Language class diagram gives us an overview of a software system by displaying classes, attributes, operations, and their relationships. This diagram includes the class name, attributes, and operation in separate designated compartments. Unified Modeling Language is a standard notation for the modeling of real-world objects as a first step in developing an object-oriented design methodology. Its notation is derived from and unifies the notations of three object-oriented design and analysis methodologies. Other ideas also contributed to UML, which was the result of a work effort by Butch, Rambo, Jacobson, and others to combine their ideas, working under the sponsorship of Rational Software. UML has been fostered and now is an accepted standard of the Object Management Group, which is also the home of Common Object Request Broker Architecture or CORBA, the leading industry standard for distributed object programming. Vendors of computer-aided software engineering or CASE products are now supporting UML and has been endorsed by almost every maker of software development products, including IBM and Microsoft, for its Visual Basic environment. Class diagram is a static diagram. It represents the static view of an application and describes the structure of a system by showing the system's classes, their attributes or class fields, the operations or the methods, and the relationship among objects. Class diagram is not only used for visualizing, describing, and documenting different aspects of a system, but also for constructing executable code of the software application. The UML class diagram is a graphical notation used to construct and visualize object-oriented systems. The purpose of class diagram is to model the static view of an application. Class diagrams are the only diagrams which can be directly mapped with object-oriented languages and thus widely used at the time of construction. The purpose of class diagram can be summarized as analysis and design of the static view of an application, describe responsibilities of a system, base for component and deployment diagrams, forward and reverse engineering. How to draw a class diagram? Class diagrams are the most popular UML diagrams used for construction of software applications. It is very important to learn the drawing procedure of class diagram. Class diagrams have a lot of properties to consider while drawing, but here the diagram will be considered from a top-level view. Class diagram is basically a graphical representation of the static view of the system and represents different aspects of the application. A collection of class diagrams represents the whole system. The following points should be remembered while drawing a class diagram. The name of the class diagram should be meaningful to describe the aspect of the system. Each element and their relationships should be identified in advance. Responsibility, which is the attributes and methods or class fields and methods of each class, should be clearly identified. For each class, minimum of properties should be specified, as the unnecessary properties will make the diagram complicated. So you need to identify the minimum number of properties only. We will not include everything. Use notes whenever required to describe some aspect of the diagram. At the end of the drawing, it should be understandable to the developer or coder. Finally, before making the final version, the diagram should be drawn on plain paper and reworked as many times as possible to make it correct. UML class diagram notation. A class represents a concept which encapsulates state or attributes or class fields and behavior or operations and methods. Each attribute has a type. Each operation has a signature. The class name is the only mandatory information. A class is the blueprint of an object which can share the same relationships, attributes, operations, and semantics. The class is rendered as a rectangle, including its name, attributes, and operations in separate compartments. Following rules must be taken care of while representing a class. A class name should always start with a capital letter. A class name should always be in the center of the first compartment, just like in the given figure. We have the student as the name of the class. A class name should always be written in bold format, depends on the tool for creating diagrams. In our case, we will use the UML application or AMLET application, which can be downloaded in Google. So, an abstract class name should be written in italics format. The image shows the structure of a class diagram to represent classes in object-oriented programming. It shows that the name of the class is student appears in the first partition or the compartment. Attributes or fields. An attribute is a named property or field of a class which describes the object being modeled. In the class diagram, this component is placed just below the name compartment, which is the second compartment. The image shows the structure of a class diagram to represent classes in object-oriented programming. It shows the attributes or fields of a class. In our case, we have the student class appears in the second partition or compartment, which follows the lower camel case format for the naming convention, since class fields directly represents the member variables of the code. Access modifiers can be represented using the minus symbol for private, plus symbol for public, the pound symbol or pound sign for protected to describe the accessibility of an attribute of a class. In the given example, we can read the first class field in the given image class diagram definition as private int id. Private, since we use the minus symbol, then int as the data type, and id as the name of the attribute or field. Operations or methods. The only way other objects can get access to or affect the attributes of an object is through its operations or methods. The operations of an object are defined by its class. A specific behavior can be performed via the operations, which may affect the attributes and relationships the object holds and cause other operations to be performed. The given image shows the complete structure of a class diagram to represent classes in object-oriented programming. It shows that operations are shown in the third compartment here. They are the services the class provides. The return type of a method is shown after the colon at the end of the method signature. For example, we have the display info method. After the colon, we use void. Void is the return value. Okay? The return type of a method parameters is shown after the colon following the parameter name. operations map onto class methods in code. In defining operations or methods inside the class diagram, naming convention should be followed just like as the naming convention in the actual Java code, which is the upper camel case except the getters and setters, because getters and setters, we should still follow the lower camel case format. Additionally, access modifiers can be represented using, again, minus symbol for private, plus symbol for public, and pound sign or pound symbol for protected to describe the accessibility of a method of a class. Notice that we include here the getters and setters because they are also methods. We can read the sample operation method definition as public void display info. Public, since we use the plus symbol, void as the return type, display info as the name of the operation or method. We can read the sample operation method definition. Another one is public string get full name. Public, since we use plus symbol, then string as the return type, since the method will return the concatenated values for class fields, first name and last name, which are both strings in a full name format, and get full name as the name of the operation or method. We can also read the sample operation method definition as public void pay tuition double amount. Public, since we use the plus symbol, then void as the return type, pay tuition as the name of the operation, double amount as the parameter since the method needs to accept values before executing the operation following the syntax for defining attribute or field inside the class diagram, not including the access modifiers. If there are more than one parameter in a method, it should be separated by comma. Remember that in the lesson about constructors, we consider constructors as methods but without return type. We also discussed that class constructors can be overloaded by providing parameterized constructors with different number and or types of data within its parameters. To represent the class diagram in a more readable way, we can include the constructors inside the class diagram, specifically in the third compartment before defining your operations or methods. So, constructors should come first, even your overloaded constructors, before writing down all your getters and setters, including your actual operations and methods. Now, let me show you a demo on how to translate the given class diagram for the student class into its actual Java code. Okay, so let us define the corresponding code for the given class diagram named student. So let us go to the Eclipse workspace, right-click your own project, new, Java class. Let's say we define this as a student class. Of course, we don't need to put check in public static void main because this will be our class for student. Finish. Okay. So right after creating the class, let us go back with the diagram. So based from our diagram or class diagram, we have ID, first name, and last name as the class fields, properties, or attributes of a student class. So let us define ID, first name, and last name. So since we will implement encapsulation, as you can see here, we have getters and setters, and we use the minus symbol. This means that this ID, first name, and last name are all defined as private. So private as the access specifier or modifier, int as the data type, and ID as the name of our class field. Okay, let us put some comments here. Class fields. Next one is private again. This time string for the first name. and same with the last name. So private string last name. Okay, so we are done defining the class fields. So let us go back with the diagram. So after defining the class fields, we have the following constructors. We have four constructors, namely the non-parameterized constructor or our default constructor, followed by the constructor with ID and first name as the parameters, followed by another constructor accepting first name and last name, followed by another constructor accepting all values for our class fields. Okay, so let us define first the default constructor. So we have here the constructors. Okay, so that will be, since we use plus sign, meaning to say we are dealing with public access specifier, then the name of our constructor, which is student, having no parameters and no body. That will be our default constructor specifically. So next constructor, according to the class diagram, is a constructor which accepts ID and first name. So that will be public student again, accepting ID. ID is of data type int, followed by string first name. So inside our constructor, we need to assign the values of our class fields. So this that ID, which means I am accessing the class field ID, I will put this particular parameter as its value. Okay, so that when the user created a student passing ID and first name as the value of the constructor, it will be directly assigned to the ID and first name class fields. So this that first name is equals to first name. Okay, so that will be our second parameterized constructor. The next constructor will be a constructor which accepts first name and last name. So let us go back here. So define public again, because according to the diagram, we use the plus symbol, student, then accepting string first name and string last name. Again, just like the previous constructor, we need to assign the values of, we passed in the parameters as the values of our class fields. Specifically, the first name is equals to first name, and this that last name is equals to last name. Okay, so last constructor will be a constructor accepting all values for class fields ID, first name, and last name. So that will be our last overloaded constructor. So public student int ID, followed by string first name and string last name. So again, we need to assign all the values from the parameters to our class field. So this that ID is equals to ID. This that first name is equal to first name. And last one, this that last name, sorry. So this that last name is equals to last name. So we are done with translating the class fields and the constructors using the code from the given class diagram. So right after defining our constructors, next is to define the getters. Okay, so getters for the class fields. Okay, getters. Okay, so according to our class diagram, we use plus, which means this will be public. Okay, so public. Okay, then according to class diagram, it should return an integer. So the colon, okay, right after the colon, This describes or defines the return value of your method. In our case, integer. So that is why right after defining public, int will be the return value, then get id will be the name of our getter. So simply, this will just return the value of this dot id. Okay, so that will be the getter for id. So next will be the getter for um, first name. So this time, instead of int, the return value is string. So again, we use public because according to the diagram, we use the plus symbol, string as the return value, and get first name as the name of the getter. So again, we just need to return this that first name. Okay, so let us fix this one. Get first name. So lastly, let us define the getter for last name. So this will be last name and this the last name. Yeah. So we are done defining the getters. So now let us define the setters. So let us go back with the diagram. So setters here accepts parameter, but the return value is void. Okay, so let us start defining set ID. So if we will try to read this one, this should be public void set ID int ID. Okay, so that will be our method definition. Again, public void, the return value is void, set ID, the name of the setter, which accepts an integer ID as its parameter. So that will be your setter. So the only thing that you need to do here is to put the value of your parameter or to assign the value of the parameter using your class field. So that will be the setter for ID. So same goes with the setter for first name and last name. But this time, so same public void set first name. So the only difference is the parameter. So this will be string first name. Okay, so this that first name is equals to first name. Okay. Then let us copy this one for set last name. String last name, and last name. So we are done defining the class fields, followed by the constructors, the getters, the setters in accordance to our given class diagram. So right after defining the getters and setters, next is the display info. So according to the display info, so this is public void display info. So I think what does it do here is just to print all the values of ID, first name, and last name. So that's the only thing we need to put inside the method. So this will be our methods. Okay, again, that will be public void display info. Okay, so for us to be able to print the values of our class fields, we need to use the command for system.out.print. So let's say print line. Okay, so let us put a label. Let's say ID. So plus this dot ID. Okay, it will be printing the value for ID and first name, last name. So this dot first name and this dot last name. So that will be the content of our display info method. So now, get full name method. So get full name method returns string. So because the idea of get full name is to print or return the combined or concatenated values of first name and last name in first name last name format. So that's why it should return a string here. So that will be public void, not void this time. It returns a string. So get full name. So take note of our naming conventions. Okay. So when we are defining getters and setters, even though they are methods, we should follow lower camel case. While if you will be defining methods, you should follow upper camel case. So get full name. So you just need to return the combined values of first name and last name. So that will be this, that first name. Okay. So to concatenate, we need to use plus sign. Okay. Space and plus this, that last name. Okay. So let us modify the display info method that so that we will be able to print also the full name of the person. Okay. So here, instead of last name, we need to put full name. So how do we get the value, or how do we call the method get full name to return and print the value of the combined first name and last name? So simply just type the name of the method, which is get full name. It will return the this that first name plus this that last name. Okay, so notice here that we have a pair of parentheses because get full name is a method. Okay, so that is how you will deal with the get full name method. Lastly, we have here the pay tuition method. So pay tuition method only accepts the amount in double data type and does not return anything, meaning it will just print the value or the amount paid. Okay, so let us go back here. So public, no return value, pay tuition, the name of the method. So it accepts double amount as the parameter. Okay, so let us copy this one and just print here amount paid. So plus, this time we will use this parameter as the value of the amount paid by the user or by the student. Okay, so considering our code, let us review this one again. Starting from the top, class fields, we have private int ID, private string first name, private string last name. Again, going back here, we have here the class name or the class fields. Okay, under the student class, this is the student class name. The constructors, for constructors, let us check this one. For constructors, getters and setters, getters and setters. Okay. Lastly, the methods, display info, get full name, and pay tuition. So these are the methods. Okay. So that is how to translate the class diagram into its corresponding Java code. Simplifying the class diagram. You may observe that in the simplified version of the class diagram of the student class at the left side of the slide, it is possible that the class diagram will be flooded by too much getters and setters. Imagine if you identify 10 class fields, it will mean that you need to define 10 pairs of getters and setters for each field. Remember that we have a discussion regarding a read-only and write-only class, which shows that it is not required to define individual getters and setters for your class fields. It depends on your purpose and how will you control the access from different classes. Now, even you have the option to make read and write only classes to limit the use of getters and setters, it is still recommended that you will not include the getters and setters on your class diagram like the simplified version of the class diagram of the student class on the right side of the slide. So this is the simplified version of the previous class diagram, not including the getters and setters, to make it more simple. In summary, we could say that the Unified Modeling Language or UML is a standard language for specifying, visualizing, constructing, and documenting the artifacts of software systems, as well as for business modeling and other non-software systems. Class diagram gives us an overview of a software system by displaying classes, attributes, operations, and their relationships. Access modifiers can be represented using the minus symbol for private, plus symbol for public, and pound sign or pound symbol for protected to describe the accessibility of an attribute or method of a class. By not including the getter and setter methods in the class diagram, simplifies the class diagram itself. Now for this lesson's activity, create a UML class diagram following the requirements. Post the screenshot of your diagram created using the Amlet application. You can download using the download link given inside the post tab of Wiki channel of our MS Teams. Additionally, the link to the video tutorial on how to use the Amlet application is in the given link also. So that's it for now. Thank you for watching and hope you enjoyed this video. For inquiries, feel free to post your questions in our group chat. In our next video, we will discuss all about inheritance. Don't forget to visit the links in the references section for more information about this lesson. See you in the next video.